Right. Thank you. Happy to be here. And my name is Peder Pedersen. I am a principal developer at Saxo Bank, and I have a background in game development before I started doing Fintech. And my start with MCP was back when it was about a month old or something like that, when I built something called MCP.net, which I started building pretty much as soon as MCP was announced. Eventually, that became the foundation of the official MCP C# SDK, which Microsoft took over and is running, maintaining now. And I'm a contributor and a collaborator on it. I am also one of the maintainers on the MCP Financial Services Special Interest Group, and I'm generally active in the MCP development community. So that's a bit about me. I'm an MCP geek, you could say. And this talk is about using MCP to power agents. So perhaps we should start by defining what is an agent, because there are a lot of definitions of an agent, and it's something that I'm sure a lot of companies and organizations, teams have struggled with. I know we've had discussions internally where we couldn't really agree what an agent was and what the right terminology was. And you see some of the examples here. And it doesn't really help that there are a ton of agent frameworks that use the term slightly differently. But eventually, this is a definition that I think you could say that a lot of people have arrived at. That an agent is a model that has instructions and context, it has tools, and it runs in a loop. There may or may not be a user interacting with it. And one of the key things making this possible and making it so that we don't have these many definitions of what an agent is that the models are now inherently agentic. If you go back like a year, the models had trouble calling tools in a loop. They would call them once, then they would ask the user for feedback. You couldn't really get a model to do this kind of act-observe loop. So this is a definition of an agent I'll go by today. And I know there are some people who talk about shallow and deep agents, and that's a completely different topic, which is also interesting. But if we look at some of the problems when you're working with agents, you have a lot of agent frameworks. You can very easily get locked into a specific framework, a specific vendor. You have language barriers. Even if you use MCP, that removes some of those language barriers. You still have data science people and machine learning people with a background in Python. You have other developers in an organization that have different backgrounds. And finally, when you write agents using code, you create friction because you need to orchestrate what is going on. You have very easily have things sneaking in that is difficult to port. And generally, code is just kind of a problem. And this is also a cloud native user group. So I'm sure there are a lot of people here who will be happy at what I propose here and what I think is a great way to build agents. Because there is a better way than writing all this code and getting locked into frameworks. And that is using the Model Context Protocol. Everyone knows the Model Context Protocol. A lot of people know it from how it can power tools. If you don't know it, then here is a turbo primer. You probably have to go read up on it to understand it. And if you don't, then you should probably go do that, pause this video, and return to it later. But let's say you do have a decent understanding of MCP, then this should make sense. MCP is a way for applications, services to provide context to a model. It doesn't actually state how you should run the model. You don't even need to run a model. It doesn't say how you should implement your tools. It wires tools and other kinds of context together with LLM or other AI-based applications. A lot of MCP servers wrap an API. Like you've probably used, if you've used MCP, you've used the GitHub MCP server, or another one that to some extent is wrapping an API or a CLI tool. But it is more than just tools. And one of the use cases where we have had a lot of benefit from MCP is for internal architecture. This is where inside a trust boundary, you have both the agent and the MCP server. So it is not in a situation where you have an external client connecting to your MCP server. It is not a situation where you have one of your clients, that could be VS Code, or it could be a chatbot, or whatever you run in your company, connecting to an external MCP server. It is where you control both parts, the agent and the MCP server. That enables a lot of architectural patterns and a lot of orchestration patterns. Examples of where this could be useful is, let's say you have a chatbot and you want to connect it to a data source. So this is your own chatbot, which is the agent inside the trust boundary. You have your own MCP server, which connects to your own internal APIs or data sources. Sometimes people will say this is a bad idea. And I've been told that you should not tell people why they're wrong, but you should tell them why you're right. And so why would you want to bundle? Why would you not want to bundle tools in the agent runtime? Why would you want to use MCP? And there are 3 reasons. First off, you can reuse tools without distributing shared code libraries. For those of you who are developers, you know how painful it can be to distribute internal libraries in an organization. You need to make sure that everyone updates to the right version. There's a lot of work in that. And you also have compatibility issues if there's a lot of different languages in use or different framework versions and all that kind of stuff. So it enables microservice for agents patterns. It is also polyglot, which is what I just mentioned with the languages. So people, developers, can write tools in the languages they are good at. And finally, this is a big one, I think, the runtime stays simple. If you bundle the tools with your agent, then it becomes complicated. Then you have a lot of code. Then you have an artifact, a service to maintain. And generative AI is already considered high risk in a lot of sectors. So the simpler we can do this, the better. And here we show it in a diagram where you have these different groups of developers working in different languages, and they can write their agents, they can write their service in what they're good at using, and they will be able to talk together. So even inside an organization, it makes sense to use MCP to wire up your integrations and your agents. And an agent can be a chat program. It can be a headless service that is doing processing. Anything using AI. So if we go back to what I talked about earlier with agents as code, which is what I sort of indicated I'm not too fond of, it could look like something like this, where you have some code that defines what MCP servers you want to connect to, defines what model to call, and then it begins the loop by sending the user message and parsing it and doing all that stuff. But what if you could do this instead? If you are a cloud native person, then this looks familiar, right? This is configuration. This is exactly the same as we had in the last slide. So all this code, all this boilerplate, we've turned into configuration. Now, this isn't particularly revolutionary. People will use configuration for the applications often. So this is just the first step. Now we've defined that we can take an agent, which is a model, instructions, and tools, and define it as configuration. Then we can go one step further. The system prompt, that is the instructions, we could take them from the MCP server as well. So instead of having them hard-coded or as an environment variable, we can take them from an MCP server. We can also do a little bit of extra configuration, and this is a little nugget of wisdom, you could say. This is a whitelist of tools from the MCP server that we want to allow this agent to use. This is a really good thing to do because if you just use all the tools from an MCP server, then you create a coupling between the agent and the MCP server, where if the MCP server changes, adds tools, for example, then the agent changes. So my advice would be to also make the list of tools that you're allowed to call configurable. But we can go one step further. Now a lot of stuff disappeared. What happened here, right? If we compare it to the one we had before, the list of servers went away, and instead we just have a bundle. That's because we put the agent configuration on the MCP server. So all of this is on the MCP server. And that means that a client can just connect to an MCP server and it can get everything that defines an agent and run it. Now, this might be a step too far for some people, and it's perfectly fine to just stay in this world where you configure the agent, and that's good enough. Declarative agent is a really powerful construct. This is something you can do. It makes sense in some cases. And then there's the extreme version, where you don't even specify the resource where you find the agent. You just give it an MCP server, which would be an internal MCP server. So basically, an agent as an MCP server. And what happened to the config? How do we find it? We can use the concept of a well-known URI, which in this case would be agent config YAML. And this would be something you define in your organization and in your architecture. It is not part of MCP. It is just an internal contract. And that highlights one of the advantages of using MCP internally, that you can define these implicit contracts and enable discovery and integrations that you cannot do with third-party clients or servers. So just to recap what happened, I covered how agents are a model, instructions, tools, running in a loop until it has completed its task or found the answer for the user. We saw how that was a lot of code, in practice a lot more code than I showed, and how we can turn that into configuration. I also showed how we can do various patterns with this configuration and have it completely on the MCP server. And as I said, if we want to get off before the last stop, that's perfectly fine. And also, now you probably want to know, how do I actually run these? Because I've just shown some YAML, and you can't run YAML. Oh, there's a little bonus, because if you read the summary of this talk, there was something about brand new features in MCP. This was back when I thought up the concept for this talk. I thought this one would be in the latest version of the MCP spec. It is not yet. It is a so-called SEP, Specification Enhancement Proposal. So it might become part of it, it might not. I think there is a very good chance something like this will be part of it. And that is where an MCP server can advertise its capabilities and its resources. And I've cut out some of the JSON here, but it would mean that an MCP server could advertise, I have a file called agent config, and then in your internal infrastructure, you can connect to it and you would know straight away what agents are available on it. And you could even define your own protocol to allow you to have multiple agents on an MCP server. There are many ways this could be used. It has to get into the protocol first, but that was just a little bonus. Okay, I want to backtrack a little bit. If you, depending on how well you know MCP, you might wonder, why not use prompts for the system prompt? Like, why is this crazy person using a resource for the system prompt? And there is a very good reason for that. The prompt feature is mostly there for things like prompt libraries, because it only has user and assistant roles. It doesn't have a system role. And you generally don't want a list of messages as your system prompt. You want a single message. You want some data or content, which is exactly what is in a resource. So resources are the best capability, in my opinion, to make agent instructions data-driven. But I think it's a good one to cover because it seems really, really counterintuitive that prompts are not the capability of choice. Another good reason to use resources is that it is really easy to read them. When we have a connection to an MCP server, all we need to do is provide the URI. And they also support URI templates through resource templates. So this is just a really good primitive for that. Finally, we return to the matter of how do we actually run this. And if we step back to when we were writing code to run agents, why do we have this agent runtime? We have it to get the base functionality of being able to connect to MCP servers, to connect to the models. So how you build your runtime will depend on what skills you have in your organization. Maybe you will build it with ADK. Maybe you will use an existing agent runner like Cagents, or you might use something like Goose, because there are a lot of runtimes and frameworks that can already use YAML files to drive agents. And the ones that cannot, it doesn't take that much to implement it. And finally, you might also want to create adapter layers so that your MCP server exposes multiple YAML file formats so that you can switch between runtimes. And this whole idea of having agents be declarative and not code, it's not just something I cooked up. If we look at Goose, Cagent, ADK, Microsoft Agent Framework, a lot of people are making these data-driven. Here are some examples and more. And this looks very familiar to anyone who's worked with Kubernetes and with config-driven infrastructure. Okay, that was a bit about why I think this is a great idea, a little bit about the different patterns you can use when you have declarative agents. Now I'm going to share some experiences that we've had using config-driven agents, declarative agents. And one of the really, really good things is that it makes evaluations so much easier to run. Evaluations are when you have an agent, you have a model, MCP servers, and you need to see how well they perform against the task they're going to do. If it's a chatbot, you might want to test if it can actually answer the questions it's supposed to answer in the right manner. If it is a task agent, you want to see if it carries out the tasks that you want it to carry out. And in order to do that, you need to be able to run the agent in a pipeline, ideally, in the same manner that happens in the live environment. If your agent is a lot of code, then you need to run a lot of code. If your agent is declarative and it's configuration, then it is the same runtime whether you're doing evaluations or whether you are running it. And even if they're different ones, it becomes much easier because you can document what it is that you're testing, and you know that your evaluations will give the same result as the live one. And it also becomes much easier to evaluate your MCP servers because you don't have complicated logic hidden in code. And something we actually saw that was that this makes it a lot easier to do optimization using evals, where you have a code agent, you give it the declarative agent, you give it the evaluation data set, it runs it, it gets a score, then it tweaks the instructions, it runs the evals again, and without having to do anything but edit the configuration, you can see the evaluations get better, see the agent get better, and that is a much faster way to optimize than hand tweaking the instructions with humans and running these evaluations in different contexts. So that worked really well, and I encourage anyone who doesn't have something like this to try and set it up. If you can't set it up, then figure out what do you need to make into configuration to be able to do this. Because our experience, we found that the instructions, the system prompt, that is a big part of the secret sauce of a good agent. You really want to be able to see the effect of changing your system prompt. And if you have your agent as configuration, then you can do that. If you have code, then you very easily get bugs and control flow. So this paradigm keeps everything simple. If you have resource templates, then you can parameterize your agents. So you can have agents where they do different tasks. They have the same system prompt, but something gets injected into it, and then it runs it. And it also works with the structured output for those who prefer that. And in some sense, it also reframes how you think about agents. An agent isn't an application. It is simply configuration for the model. It is wiring up the model with context and tools. And that is what we want to optimize, what we want to engineer to give us the best possible result. You could say that it makes AI engineers work in a more data science oriented way, working with data and with quantifiable outcomes. And it also makes data scientists able to focus more on engineering selectively and smartly. They don't need to write a lot of code. They just need to write the agents and run the evaluations and do what they're good at. There are challenges, of course. Sometimes you want agents to be part of workflows. You might want agents to hand over work to each other. You might have things that are difficult to represent with tools, which could be moderation, for example, if you want to see if some user input is bad and then you want to reject it. And there are cases where this can be complicated. But I would still say that you should try to make it declarative, try to avoid putting behavior into code, but see how you can express it as tools, as configuration, as templates. And often you can even get very far just by having a better system prompt. It's something that looks like a problem where you need to solve it with complex workflows is something the model can do on its own if you give it the right information, the right tools. Tool middleware is also a challenge. And there are other challenges. I won't go too much into detail of that because I'll probably run out of time. And also implicit contracts can get out of sync. That was the thing I advised before, where you want to whitelist the tools, because if you don't, then you release an MCP server, you have more tools, the agent acts differently than when you evaluated it. And there are some things which might even be downright ugly. Sometimes you work with agents that are scripts and you don't really want to have a complicated pipeline where you need to create a config, you need to deploy it, you need to have a runtime orchestration, all that kind of stuff. You just want developers to run them quickly, but they can still do that. I'm not saying that every agent has to be like this, just that many agents benefit from this. It might also conflict with low-code, no-code platforms where the output of configuring an agent might not be YAML, or it might be internal YAML, or whatever configuration format. And then there's a whole thing with having to write the runtime and the adapter if you don't have one. So to recap again, we have models today that are inherently agentic. We don't really need to help them loop. We just give them the tools and the context. MCP can provide both of those. The tools everyone knows about, but context can be provided through resources. And that means that the runtime is essentially an MCP client host. It needs to integrate with an agent framework or an LLM wrapper. And then it needs workflows or connections. That depends on your organization. But you should start with what you can make configuration driven, which is the context and the tools. Finally, I think it is important to note, especially for an audience where there might be a lot of developer platform people, a lot of infrastructure people, that running an agent takes very little compute. What requires resources is the inference. So that is probably remote, some provider API, because the AI is with one of the big labs or the big cloud providers. Or if you run your own models, then that is a different thing to manage. So it is important to separate the concerns of running the agents and running the inference of the models. Those are two different things. But when orchestrating agents, you want observability, resilience, and auditing, classic software service, microservice concerns. You could embed your runtime inside an existing service. That is how a lot of people who follow this approach start. So you have an agent, you have set it up with tools, you have the system prompt in code. That's where you start. Then you put the system prompt into configuration for the service. And then the next step is to put it into an MCP server. So take small steps if you want to follow this. Don't over-engineer stuff. And also, don't be afraid to have developer runtimes. You can have multiple runtimes that can run your agent configurations. And it can be very helpful to have a stripped down version for running locally for development and for debugging. So this turns agents into resources. They're not programs, they're not code, they're just resources, and you can deploy it like any other configuration or service. You could even draw parallels to the world of containerization, where you have an agent definition is somewhat the same as a container. The runtime is the same as the container runtime, and an MCP server is, of course, also a resource, because that is actually code and a service running. And this enables all of the patterns that are so good from the cloud native world that we already know: scaling, A/B testing, multi-tenant deployments, all this stuff. Another thing that is important when talking about agents is that agents are less durable than services. If you have an API service or some other service, it is usually a project with a lot of developers. It runs over a long period of time. It is maintained. It is run. But agents are not like that. You want to be able to quickly create agents, and you want to iterate on them fast. So the runtime is a durable, and the agents is a disposable. And also the declaration is the artifact. There's no code. Another thing which is important is that rate limiting matters. You could have agents that use a lot of resources, and then you would need to rate limit them. Authorization is difficult. You have the agent identity. You have the user that is starting the agent or conversing with the agent. They have an identity, and you have a service identity inside the MCP server and inside the runtime. And it is very important that resources are accessed with the right authorization. So even if you have infrastructure that handles all of this, there are complexities about which identity to use for a given agent. So if we return to the original definition of an agent, where you have instructions, context, tools, running in a loop, acting, observing until it is done, you could fold all of these together and say it is just a model and context, which means that the model context protocol is perfectly designed to power agents, because MCP is about context, and everyone knows tools, but there's other kinds of context, like a resource, which could provide the instructions for an agent. And there are many other features in MCP that could power other parts of the agent. Some of the complexities we mentioned before, maybe some of these can power that. That is to the individual organization to discover. Finally, AI technology is moving so fast that we cannot have paradigms, cannot have services that are slow to develop and to iterate on. We need to move fast. So the more we can decouple the more we can use configuration over code, the better. I'm a developer. This has been a somewhat technical talk. I love code, but I do not want code in my agents. Sometimes I cannot do without. That's okay. But you want as little code as possible. So I encourage everyone to explore MCP, learn more about it, and see the ways in which it is more than tools. You can use MCP servers internally in an organization, in a company, to drive your infrastructure and make more of your AI infrastructure into something that is powered by configuration, by declarations. Thank you. You can find me on GitHub and on LinkedIn if you want to reach out, or you can ask questions in the chat.